Okay, welcome to part 2 of the problem solving video on geometry. So first question we have here is how many times bigger is the volume of a cylinder if the radius is tripled? And notice it doesn't tell you anything about the radius as it starts or the height. So what we would want to assume is that, let's say we don't know that. Let's just draw a cylinder. Okay, and this could be just any cylinder. So we're going to assume that the radius is unknown. And usually we use R for the radius, and we use H for the height. Okay? Okay, so R is the radius, and the volume of a cylinder, is pi times the radius squared times the height. Now, a simple way to do this is, let's just take an example one. It says, it seems to imply that it doesn't matter what the radius is to begin with, or the height. So we can just pick a number for both of those if you want. You can make it really simple. So let's take a cylinder and say we have a cylinder here, and let's make the radius equal to, what's a super simple number? Let's say the radius equals 1. And let's also say the height equals 1. So if we did that, the volume of a cylinder with a radius of 1 and a height of 1 would just be pi. And now, the only thing that's supposed to change is the radius is tripled. So it's going to go from 1 to now 3, right? So the height's still 1, and now the radius is going to be 3. So our volume is going to be pi times 3 squared times 1. And so that's going to give us 3 squared is 9, and 9 times 1 is 9 pi. Now, I know you can, pi is 3.14. We usually leave, unless we're estimating, we can leave the volume in terms of pi. Now this is going to be, we don't know what the units are, so I'll just write CUUN, which is cubic units. So it looks like the radius, the volume went from pi cubic units to 9 pi cubic units. So it looks like the volume is 9 times the original volume. So it appears as though the volume of this, how many times bigger is the volume of a cylinder if the radius is tripled? It looks like it is 9 times bigger. Or 9 times as big. How many times bigger? 9 times as big. Let's just double check that. If you had something else, we would say, well, let me show you how you could do that. Another way you could do that. Let's just say in general, the volume is pi r squared. What if r is this? Something that had 3 times the radius, if the radius is tripled, you would take that r and you'd replace it with 3 times whatever r is. It doesn't matter if r is 2, if r was 2 here, if the radius here was 2, the radius here would be 6, right? 3 times 2. Or if the radius was 12, this would be 3 times 12, which would be 36. So this is always going to be 3 times that radius. So the volume of a sphere is pi times radius squared times h. If you substitute the radius with something 3 times as big, then you get pi times, now what's 3r squared? It's 3 squared times r squared, which is 9r squared h. And now if I pull that 9 out, I rearrange it, that's the same as 9 pi r squared h. So in general, the volume of any cylinder is pi times the radius squared times the height. The volume of any cylinder, if you multiply that radius by 3, will give you 9 times pi times r squared times h. So clearly, this is just 9 times bigger regardless. So that's 9 times as big. So how many times bigger is the volume of a cube if the side lengths are doubled? So first of all, the volume of a cube, we need to a cube is a rectangular prism with length, width, and height the same. So we usually call those S, S, and S. So in a cube, we often write it as volume is equal to the side length cubed. Okay, so it's S by S by S. Oops. So what happens if you triple or double that? That means instead of S's, all these S's are doubled, no matter what it is. If that's like a 5, 5, and 5, it'd become 10, 10, 10. Or if it's 8, 8, and 8, this would be 16, 16, 16. So whatever S is, if we double S, whatever that is, we'll put in a 2S in place of it. So the volume will not be just S cubed, it will be 2S, that's an S, cubed, which is going to be 2 cubed times S cubed, which is equal to 8S cubed. So instead of the volume being S cubed, if you double every one of those, it's going to be 8 times what S cubed was. So it'll be 8 times as big. Okay, so let's go ahead and move to another problem. Okay, which is bigger? A cylinder that has a radius of 8 inches and a height of 6 inches, or a cylinder that has a radius of 6 inches with a height of 8 inches? And then it says explain. So to find out which is bigger, we could just calculate the volume, but to do that, let's try volume number 1. A cylinder has a radius of 8 inches and a height of 6 inches. So remember, the volume for any cylinder is pi r squared h. So let's call this for A, the radius, when the radius equals 8 and the height equals 6, that's the volume is going to be pi times 8 squared times 6. And for, let's call it B, cylinder B, it's a radius of 6 and a height of 8. So here the volume is going to be pi times 6 squared times 8. And I think that a lot of people would prefer to just calculate it. But that doesn't help us explain very much, does it? That's not much of an explanation of why one is bigger than the other. If you write this out, this is 8 times 8 times 6, and this is 6 times 6 times 8. So if you did the calculation, which we don't even have to calculate, we can see pi times 8 times 8 times 6 is going to be bigger than pi times 6 times 6 times 8. Here you've got 8, 8, and 6, and here you've got 6, 6, and 8. So because, look at the difference, both of them have a 6 and an 8, right? There's an 8 and a 6 in both of them. But the difference is when the radius is being squared, that gives you an extra 6, and here with the radius being bigger, that gives you an extra 8. So in other words, you could say the one where the radius equals 8 is bigger because the radius is squared and the height is not. So that would be an explanation as to why, explain why that would be bigger. And in general, the radius has a bigger impact on the volume than the height. Okay, so lastly, we've got another problem here. It says, there's a black round of cheese, and it says it costs $9, and the red block costs $7. So if I scroll down, I see the red block, and I see the black round. So this is a $9. The black one's 9, and the red one's 7. It says, show how to determine which is a better buy. And we're supposed to assume the cheeses pictured here are the same type and similar in density. So to see which is a better buy, I might compare the price of this block of cheese to its size and the price of this block of cheese to its size. And since these are two different shapes, the size, we would say, is based on volume, right? So on this one, it's going to be $9 for what volume, right? So I think a reasonable way to do this is to compare the price to volume and see, well, which might be cheaper per unit volume, right? Does that make sense? So we get like a price per cubic inch or whatever. I am going to take a ruler, which you will all need for this material. You're going to need to measure it. And so I'm going to take this and put it up to my screen. So I'm going to show you what that looks like. I'm going to put this up to the screen, and I'm going to measure that. I'm going to use centimeters, not the inches. So when I use the centimeters on that, that looks like about almost 3 centimeters high. So that's the centimeters is about a height of 3 centimeters for that cylinder. And then as I measure across, that is 11 centimeters across. That's the whole diameter. And remember that get this back on there. Remember that the diameter is twice the radius. So if it's I'll write on here that I had a height of 3 centimeters and a diameter of 11 centimeters. So that means the radius will be half of that, 11 over 2, which is 5.5. So the volume of this is, remember, a cylinder is pi r squared h. You're going to need to have that handy. And that's going to be pi times the radius is 5.5 squared times the height is 3. If I do that calculation, pi times 5.5 squared times 3, I'm getting 200. That gives me a volume of 285. Yeah, 0.09, it doesn't really matter. This is all estimates, so I'm just going to say about 285. 285 cubic centimeters, and that was $9 for that, for 285 cubic centimeters. And so I'm going to calculate the price per cubic centimeter. So 9 divided by, now I'm going to do it in cents. So I'm going to change this dollars to 900 cents, because then we get a bigger number there. Because I'm going to do it in cents per cubic centimeter, divided by 285, and we get, I'm getting 3.16 cents per cubic centimeter for that. Oops. I'll just write cm with a third power there. So we'll jot that down. And now I'm going to scroll down and take a look at that block. And this was $7, right? $7 for the block. And so now I'm going to measure that. So you can see my measurement here. I'm going to say that is the block height down below there. That's about 2.8 centimeters. And this is almost exactly 5. I'll say 5.2. So I'm going to write that 2.8 and 5.2. And this is a rectangular solid, so its length times width times height is the volume on this. So 2.8 times 5.2 and times what's the length here. And of course, this is just a picture, and it's just a crude way of doing this. So that's 13.5, it looks like. So 13.5, and those are all in centimeters, so we're going to have cubic centimeters. So I'm going to now multiply those. 2.8 times 5.2 times 13.5. and that is 196.56 cubic centimeters, and this was $7 for that much, which is like 700 divided by 196, 700 cents, right? Divided by 196.56 cubic centimeters. So what's the cents per cubic centimeter there? Is 700 divided by that answer, and that gives me 356 per cubic centimeter, right? This is cubic centimeters, and that was 356, and this was 316. Three, not dollars. This is about 3.5 cents per cubic centimeter. This is about 3.2 cents per cubic centimeter. So they're not really very different in price, actually. But that's just to give you an idea of how you could do some calculating. And you'll see some other videos where I do watermelons, which aren't perfectly spherical. So I kind of measure those. I draw a circle around it, kind of a little, cut it. So I'm just estimating it. And so you should watch those videos too for volumes of unusually shaped objects that would kind of make an estimate, and we use a volume for a sphere on that, which is 4/3 pi r cubed. But that's a different video. So that's all for this video. That's video 2, and that's geometry. And there's lots of other videos on problems that you'll be solving. So I hope this helps. Bye-bye.